So thank you guys all for coming. This is awesome. I was expecting to get Rasmused by a couple of the other talks, so happy to see people in here. So if you went to Eli's talk this morning, we're going to go over much of the same things that he went into, hopefully in a little bit more detail in some, a little bit less in others. What this talk is about is if you're interested in learning how to secure your website. So basically the bad guys already know how to do all of this stuff. I'm going to try and share some of that information with you so you can learn how to prevent it on your own websites, how to identify when you've got vulnerable code. So we're going to learn how these happen, how these exploits can occur, how you can find code by inspection or by, say, searching GitHub that is vulnerable, and how to attack your own websites. And that's a very important thing. This is not something that I want you to take out and go and attack other websites. This is something where you really need to have permission to do this or do it on your own things. Now, if you want to practice this sort of thing, there's a couple of web applications that are out there that are pretty neat. There's one called Damn Vulnerable Web App that you can download. It comes as a VM. You just start it up. And then it has all sorts of vulnerabilities that you can try out. And it has different levels of security. So just by changing one of their settings, you can take it from low or no security up to medium and then up to supposedly invulnerable. And so you can see how the code changes as you move through those steps. So the code that I've got in here, it is similar to real code. It's not real code. If it was real code, it's been fixed then, at least as far as where I found it. But it was written for this presentation. So the first and the most common exploit is going to be SQL injection. SQL injection is how a few months ago NASDAQ got taken out. So it is very common. This is a little snippet that could be from PHP, most likely, because you've got the super global post. And what's happening is we're taking that variable and we're shoving it directly into a query. Now, back in the early days of PHP, this sort of thing was everywhere. That's how the tutorials went. They said, do this, or it'd be $_get, or $_request, or the long versions of those that don't seem to be around anymore. So the reason why this is important and why this is a vulnerability is because the SQL engine, the database that you're going into, doesn't have any way to differentiate what is instruction and what is code. And that's the basis for pretty much any sort of injection attack, is when the interpreter, the thing that's reading this, can't tell what's supposed to be data and what's supposed to be instruction. So if the user were to come in and they were to post something like this, so we've got single quote or 1=1, semicolon, dash, dash, that's going to go into a query that looks like this, which is legitimate as far as the database engine is concerned, and you're going to get the users where the username is blank or 1=1. Well, 1=1 is always true, and we've ORed it together, which means we're now going to get every single user in the database is going to be returned when we run this query. So if you're doing this as a login system or something like that, you're going to get a user back, right? Now, you can do other things as well to prevent this sort of thing. You can say, well, I know that I'm supposed to get only one user back, right? You can throw a limit clause on there. Now, limit's not going to help you with the SQL injection, but your code can go and check and say, did I get only one thing back? If I didn't get one thing back, or if I got more than one thing back, there's big problems ahead and we should do something about it. SQL injection can happen, obviously, through get, post, and request. These are the easiest and most common ones. If you do searches on GitHub, you will find close to 100,000 queries where somebody is running a select or an insert or an update or delete with one of these as concatenated directly into the query, which means that their particular application is vulnerable. You can search on the internet for that as well, but GitHub provides nice little things. You basically say, give me select in the vicinity of a $_get or post or whatever, and there's tens of thousands of each of these. So not only can we SQL inject with any of these, we can also SQL inject with cookies, right? So I've seen web applications where the cookie value is used to prevent you from, say, logging in more than once, right? So they store a session in a database somewhere and they look that up. So they take the cookie value, your PHP sysID or whatever they want to call it on the application, and they passed it directly into a query, which means I can control the cookie value so I can SQL inject the application, which means I can log in without ever providing credentials, but SQL injecting the cookie. You can also SQL inject through values from the database. This is something was allowed through, it's now treated as good data, it's not escaped properly, and when it goes back into the database, we've got problems again. Some parts of the superglobal server are also user controlled, okay? And those can all be used for SQL injection attacks as well. When you have errors turning on that the user can see, this helps the attacker find out what's going on. So if you see a stack trace, for instance, shown up on a production site, this is very bad. You can see where files are located, what the calls look like. Sometimes you can see parameters based on what the settings are on the server for the stack trace. All of these things help the attacker plan their next step and what they want to do. And you attacking the website can use this as well. So we recommend always turn display errors off in production, but you do want to go ahead and log those. We want to know when we're being attacked. We don't want to do anything that helps the attacker find out what they can do to further compromise our system. So the next one is blind SQL injection. So this is where we don't have errors turned on, but we're going to use system calls and things in the SQL that we can take a varying amount of time or change the response to allow us to answer questions little by little. So I've got a few examples here. So let's say this is your website that you're attacking. This is a normal URL. You've got a page or a news article ID that gets passed in, and this is what they use, right? This is, you know, old school kind of routing, but the same exact thing applies if you've got fancy, pretty URLs. So one of the first things that we want to try is change the URL. So we add this on there. Now this is going to get URL encoded and everything, so the spaces become %20s and all the rest. But if you pass this in and you see that there's no change at all in the output, then you've got a very good chance that there might not be any validation on this field. Okay? So now we try it in a slightly different way, and we say, okay, well, let's make it so that this query is not something that is true all the time. We'll make it something that is false all the time. Now, if we do get a change in the output of the page from the first two on this point, we know there's a SQL vulnerability. We may not be able to see it, but we know that there's a problem. Okay? So now we can start exploiting that. So we can do something like this, and we can say, all right, let's figure out what version of the database we're running. Okay, so this query, when it tacks in at the end there, is going to find out what is the major version of the MySQL library or the MySQL server that we're going against. And if it's true, meaning if that substring is 5, and our first thing said no changes, we're going to get no changes. This will run just like everything else. If it's not, we're going to get the changed or modified output, right? So we're asking yes or no questions as we go along. If we get a question answered and it says yes, basically the output is the same, we move on to the next part of the version, and we can find exactly what version they're running and see if there's any particular exploits for the database in that way. We can query the capabilities of the database. So if we do something like this, we can see, is the database vulnerable to subselects, or does it have the capability of running subselects? If we get an output page that looks completely normal at this point, we know that they've got subselects turned on. If they don't, then they're not available to us. And so we're probing the database to find out what kind of things we can use to attack it. We can use a query like this to determine, can we get access to other tables within the database, right? So we've got our select from MySQL user, right? If we can do that and it equals, if we get back 1 and again no change, we know we can start accessing other tables as well. And so from that point, we can start guessing tables, right? So if we get back a positive query and no change again, we know that there is a table named users within the system. If you guys have any questions, please let me know, by the way. We can start guessing column names. Now, presumably if we've got a users table, we probably got a username column and a password column, and we can guess those things as well. But we can also start guessing little by little what these names would be, and that's one way to do it. Additionally, we can start guessing data. So we may not know any of the usernames that are in a table, but we know from our previous ones that we've got a user table and we've got a username column and we've got a password column, and so we can start guessing character by character what the data is in the table. So we can use that to guess password hashes, we can use it to guess usernames, and so on. So we're going to write scripts to do this, right? We're going to have something that does this automatically. This would be very tedious to do by hand, but for a computer program to just run through a bunch of characters, it can easily find this stuff pretty quickly, especially if the application in question doesn't have any sort of rate limits or anything like that. So we just are going to guess, or we're going to increment this value. We're going to guess letter by letter, moving our subselect up and until we find out whatever it is we're trying to find. So there's a number of ways that we can prevent SQL injection. If you're using the MySQL library, I would say stop using the MySQL library. At least use MySQLi or preferably PDO or something based on PDO. The best way, I think, is the prepared statements, as Eli said this morning. And this is essentially telling the database, this is instruction and this is data, and it keeps them separate. So there's no possibility of it getting confused about what is data and what is instruction. And again, that's the root of all of these injection attacks, is not knowing the difference. The database can't tell when you stop doing data and you're now in instruction, you've got a SQL injection. We can also do input validation and whitelists, and this is also important. This comes later as far as filtering input and escaping output. If we know that a user ID, for instance, is going to be an integer, we have no reason to allow something that has letters or symbols or characters in it, right? So we can get rid of all of that stuff, reject the request. Any number of those things will also help us so that they can't do things like that. So the next exploit is cross-site scripting. This is a very, very common, very popular exploit as well. And it is essentially user-supplied code running in the browser. So, or attacker-supplied code running in the browser. Now, this may not seem like a big deal, right? It's their browser, it's their code, but it might not be their code. It could be the attacker's code, not your code, but it's going to be presented from the website as though it is their code, or rather your code. The browser's going to run it, and it's going to allow it to do anything that you would be allowed to do if it was your code. So this next code example is very similar to one I found, but we had an application that allowed you to click on a link to print an image, right? So very simple. This is basically the entire PHP script. Is it made an image link, and then it had some JavaScript underneath it that opened up the print dialog and said print, right? So you'd click the link, it would pop it up, and you would just hit OK, and it would print it for you. So it may not seem terribly bad, but we now have control over that image, right? Which is coming back from the server, okay? So what can we do with that? Well, we can steal session cookies. We can steal browser information. We can do just about whatever we want. We can call APIs that are provided by your site and cause cross-site request forgery attacks. We can post forms. So we have a lot of functionality that we can do on that website based on allowing the attacker to send stuff in. So if we pass in something like this as the value for post, we get a pop-up. This is one of the easiest ways to determine if you've got cross-site scripting vulnerabilities, is just pass in an alert. Now, just because this doesn't work doesn't mean you don't have cross-site request vulnerabilities. It just means maybe they've done something like strip out alert. But we can still keep going on that. So what about if we make it a little bit more interesting? So in this example, we've got some JavaScript right here. And again, it doesn't know the difference between what it's supposed to be an image and when it stopped being an image and started being instruction. So in this case, we have an image tag, right? And it's going to attacker.example.com session.php. And it's concatenating on document.cookie. So what does that do? Well, when the JavaScript goes onto the site, it runs in your browser and it takes your cookie. Now the browser's not going to give your cookie to anybody but that site, but as far as it's concerned, it is that site. We just happen to make it part of a URL to a PHP script that we told it was an image, and the browser is happy to load an image automatically. So let's take a look then at what session.php might look like on attacker.example.com. With this simple of a script on their side, they can grab the session from the get variable that we passed in on the image, and they can create an email and send themselves an email, or they can put it in a database or whatever else they want. So as soon as you click on that image link, they get an email, and it captures your session, right? So now we've got the session on the attacker side. We take that session, and we put it into a cookie, and we hit the website. For all intents and purposes, I'm now identified or authenticated as that user. Now there are things that we can do to prevent that. Eli talked about a few of them in his talk as far as making sure that our browser identity or our browser string is the same, and some other things that would change, right, if you were on a different browser. But the attacker can steal that stuff as well, right? With that same sort of a script, they can write those same bits of information. The string, the browser string, is manipulable. There's plugins for Firefox and Chrome and everything else where you can take that and make it be whatever you want. So we can't necessarily rely on that as well. So we can now do anything on the site as the user whose session we stole. So here's how we can use it. The first thing we do is we're going to create an email. We're going to put a link in that email to our site. That's going to send a post over to the script that's vulnerable, right? Remember the original thing, we had an image tag that takes a post, so we've got to send in post. They click the link in their email, it goes to the site, immediately redirects them off to the site that they know, the site where they may be authenticated, but it has our payload sent across as the post. So now we can do whatever we want. Just by clicking that link on the email, we've now stolen their session. So as I said before, we can do cross-site request forgery. This is faking a request as though it came from that user, causing things to happen. So Eli's example was putting things in the Amazon cart. Potentially anything, right? If Amazon had a cross-site request forgery vulnerability that they didn't close, we could purchase things on their behalf. They have this nice little one-click feature, which means we only have to send a little request and it's going to go through. So we can purchase things, we can change their passwords, we can take over their account. So we can prevent this sort of thing by escaping our output. And this is critical. Output escaping, though, needs to be done on a case-by-case basis. We need to know where it is that we're going to send our data to, right? Escaping for a database is different than escaping for a web page. It's different than escaping for JavaScript. And so you don't escape when the data comes in, you escape when the data is going out. And you escape it based on where it's going to go. We can also whitelist the URLs and things where things come from. That being said, things like your referrer, those are also user-provided data. The browser can do that, and you can hack that stuff. You can make referrer say that it's anything you want. So if you're just relying on a referrer, it's not going to work. We could also have updated that print page so that it can't take any sort of URL. It can only take maybe an image ID or something like that, and then it does a lookup maybe in a database to find the image that we need to print out, or pathing, or any. There's a number of things that we can basically say it's okay as long as it has these characteristics, right? But we don't want to just say anything is okay for this script. Now the cross-site request forgery, that's the making a request on the behalf of the user, we can prevent that by using a CSRF token, right? This is, we basically get a hash that comes back in the form. It's unique to that user. We store it in the session. And then when it comes across, we make sure that any requests that come in have to have that token with them. So the attacker's not going to have that, right? Because he didn't actually hit the web page. He's trying to make a request into a web page without that. He's not going to have it, and so we can prevent that from occurring. So in general, what we want to do is filter our input. So we know what's coming in. We want to validate and see that our input is of the type we want. If it's integer or a string or some other type, we want to make sure that we escape our output, and our output needs to be escaped based on where it's going. This will help you prevent SQL injection, cross-site scripting, and more. The next one is command injection. So all of these commands, shell exec, exec pass-through, system, and using the, I guess the backtick operator, it's the one on the top left of your keyboard underneath the tilde usually. All of these things are going to run something on the shell. If you're doing any of these and you're using them with user-provided data, you have a potential for a command injection problem. So what would this look like? Let's say we've got a PHP file web browser, right? So we've built a little script that allows you to browse the contents of a directory, right? Maybe it's made as an admin tool or something like that. So we pass in the directory and it does an ls and it gives us back what's in that directory, and we can take this and format it and make it all nice and give them some kind of a cpanel-like thing, right? Well, the danger is get, again, is completely vulnerable, right? So what if they tack in some additional things and we say get is dot semicolon rm-rf/star? Well, we might be okay. We might not. It depends on who the user is running as. Well, we're not going to be totally okay, but we might be completely screwed to mostly screwed, right? If the Apache user, for instance, is running as root, their whole computer is getting wiped out by this, okay? We could also do things like pass back additional information. We can cat their password file, cat the shadow password, so we can take it offline and start trying to crack passwords. So how do we prevent this? Well, if we're going to do this, and I'm not recommending that you should, but in certain cases you do need to run this, run all of the arguments through escape shell arg. This is going to escape them for safety in a command line. It's going to put quotes around them and keep it so that, again, it knows what's the difference between an argument to a command and what's a command. Because again, we're just confusing the, we're not confusing. Computers don't get so confused, but it doesn't know the difference, right, between what is command and what is an argument. So we run it through there, and then we pass it on, and it ends up as ls minus al, and then the directory or whatever is in that directory thing will be all quoted out, so it knows that that's a full argument, and it's not the end of a command and the start of another one. So we've got additional types of injection that can happen. We've got code injection. This is if you're ever running eval. As Eli said this morning, don't run eval. There are very, 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 very few cases where you want to run eval. Now, PHP unit runs eval. It's for a very specific purpose, and we're not running PHP unit as taking input from our website and doing stuff with it. It uses eval in order to create mock objects and things like that. So it builds up strings of class data and then runs it so that it can dynamically create classes for you. That being said, don't run eval. You can do regex injection. Now, this is an interesting one. You might not think that regex is vulnerable, but you can craft a regex in a certain way where it will bring down the computer that it's running on. Regular expressions have a feature where they can backtrack what they're doing. So you can build up an expression that says, okay, I want to find a group of things that's in a group of things that's repeated, and it will, depending on the size of your input that you're going across, you can make it run for a very, very long time. There's a, if we've got time at the end, which most likely we will, there's a site called Regex Fiddle that came out not all that long ago, and I thought, well, let me try this. And sure enough, crashed the crap out of my browser. So there's also log injection, right? Log injection is where we're confusing the human, essentially, or potentially, depending on how they are, how the site that we're attacking is dealing with the logs, potentially confusing their log parser, right? So imagine if we are able to control some part of the log, we can go and throw in some new lines, make it look like it's a completely separate login, masking the fact that maybe it said, hey, there's an attack occurring, but we put in things on there that say this particular user logged in successfully. LDAP is also vulnerable to injection. So it's another query language that you can get into and cause problems there. Is it? Good. So there's a number of other exploits as well. We've got authentication and session management exploits. So we talked a little bit about that, stealing people's session. When you are moving from one authentication level to another, for instance, logging in, you want to change your session ID so that an attacker is not going to follow along with you if they've got your session. We've got information disclosure. This is giving the attacker more information than they need. And this can come in all sorts of various forms. Even giving back the PHP version with our response can potentially give them information that they can use to attack you, right? If you're running an old version of PHP and there's known exploits for it, or an old version of WordPress or whatever else, the attacker can find out this information and go and look in their database of exploits and find different ways to go after your code. Sensitive data exposure, this would be things like putting passwords or social security numbers or credit card numbers in logs or elsewhere, right? We don't want to do that. File upload flaws. If we're allowing any sort of upload, we need to be very careful about what sorts of things we're allowing in the upload, how large they're going to be, where it's going to go. We want to make sure that the uploads aren't going to go in some place that we're going to accidentally be able to run it as code, right? Imagine a site that allows you to upload an image, but you upload a PHP script, right? If we can get the code to run or be included, we've now got potential control over that system. In addition, though, we need to be careful with those files we uploaded. Even if we check and we say, okay, is this an image? Depending on how we're using that, we could also open ourselves up to things like SQL injection or cross-site scripting through image uploading, right? If we're, say, running a site that does file upload or photo sharing, like a Flickr sort of a thing, right? And we read the EXIF data, right? EXIF could potentially contain executable code, JavaScript or otherwise. And depending on how we're handling that, if we're storing that in a database and then later outputting it without making sure that it's not containing code, you may have a vulnerability for cross-site scripting by using EXIF data, right? The camera data that comes in the photo. Unchecked redirects. This is where you go to a site, potentially you're not logged in, they redirect you off somewhere else. If we can get control over some of that stuff, we can redirect off to another site that might look exactly like the site you went to, but it's not, right? Imagine going to your bank site and it redirects you off to a different one. You may not notice that the URL has changed to some attacker's website, and now you've got a problem because you go and log in, it says, oh, I can't log in, but they've stolen your password and username already. Leaving in var dumps or other debug code. This can give an attacker more information about some of the structure, whatever you may be outputting, your directories, your objects, whatever may be in that debug, so it's a bad idea. Session fixation is where we go and we say, all right, as the attacker, we know what the session is. We've somehow passed it into your application, and you're now stuck on that session, or we know that session. So we don't even have to steal it because we gave it to you. Eli had some examples of this as well, but if you allow sessions through not cookies, this is very possible. So you have a get parameter on your URL that's PHP sessid or whatever the session ID of that particular website is. We pass that through, we know what your session is. And now we can add it into a browser, we take over your session. One thing that's often overlooked is internal threats. If you're in a company where you don't have any security on your internal applications, much of your threat can come from your own employees. So we need to make sure that the employees are able to do only what they're supposed to be able to do. Having authentication, access control list, ACL, that sort of thing, so we can prevent that problem as well. If you've got wide open applications on the inside, somebody gets pissed off, they decide to leave the company, they may go blow away your database through your web application, even though they don't actually have, say, database access. And then we've got privacy violations like passwords and logs, things like that. So some mitigation for this is we can do validation on the client. Now, validation on the client is good, and we can use it for enhancing our security. However, it's not enough. You still have to do validation on the server side. But we can do validation on the client side, and we can say, okay, if we know what we're getting from the client side, we know it's going to be valid, assuming it's a good request, and if we get something in that doesn't already validate when we get to the PHP side, we can log that as an attack. We can reject the invalid request, the not scrubbed stuff. We can log it as an intrusion attempt because they wouldn't have come through our code. Now again, I got to repeat though, you have to do the validation and the filtering on the server side. It is not enough to do the validation on the client side. Validation on the client side is nice for the user because it can help them clean it up, and then we can also use that in combination with knowing that it should be valid by the time it gets to us on the server. And if it isn't, it's an intrusion detection or an intrusion problem. Principle of least privilege tells us that whatever our users are allowed to do should be the least amount that they're allowed to do in order to get their job done, right? If we apply this across the board from sysadministrators all the way down, it means that if, for instance, an attacker takes over a developer's account, he's only going to be able to do what the developer is able to do. the developer's got sudo and everything else, he's going to be able to do everything that the developer's able to do. This goes all the way across the board, right? If you say, well, the CEO is the CEO, he should be able to do anything, you take over the CEO's account, you can now do anything, right? And again, filter input and escape output. Make sure you know what's coming in is what you expected, and when you put it out somewhere to a browser, to a database, wherever it may be, make sure that you're escaping it appropriately for that output. So I've got one more exploit. This one's pretty interesting. This is called session puzzling, and that link, and I'll put the slides up later, that link links to a PDF explaining all about it in detail. But essentially what this is making requests in particular orders, right? So that allow your request to become privileged when it wasn't initially. So let's say we've got a page that requires authentication that looks for a value in a key called user in your session, right? So not a big deal on its own. We say you have to have something in user or you're not authenticated, right? Let's say we also have a login page that has a link over to a forgot password page, and it temporarily stores whatever you put in your login page when you clicked on forgot password so that we can put it into the next field, okay? Now if we can hit these pages quickly in this order, we're potentially allowing it to get into a privileged page because we've put something into the user variable, right? So this comes down to timing and a little bit of luck, but it can happen without you really having to do anything. You can automate this sort of thing, just hit pages in a bunch of random orders, hit non-privileged pages followed by privileged pages, non-privileged again. And if you hit them fast enough and in the right order, and again, some of it just comes down to luck and hitting it, you can actually get into some websites this way. This is a very, very difficult one to prevent, other than making sure that you're not doing something like putting things in the values where you think that they're going to be privileged. This particular exploit was found by accident. It was found by a web crawler. So these guys were looking at their logs and finding that this web crawler was coming along and all of a sudden was getting into privileged pages. Well, it didn't have authentication. It wasn't logged in. There's no way it should have done it. But by following it back and tracking through, they were able to determine that that's what was happening. So, is there any questions at this point? Because I'm just about done. 15? Any questions? If you want, we can look at, oh, there's one more I can look at, I can show you on live. There's the link to my talk. I would appreciate it if you can go there and rate me on Joined In. And then I'm going to go and jump into, yes? Sure. I don't have an example on hand, but there is, if you Google LDAP injection, you'll be able to find how to do that. Yeah.
So I'm not a coder.
Okay.
Are the types of exploits that you were showing there, are they usually being run scripts or automated?
Usually, yeah. And so essentially at the point when you have an IP address that goes live on the internet, within a matter of minutes, even if you haven't told anybody, there's people scanning, and you'll see attacks come in through your logs where they just try a bunch of different stuff. You'll see really weird strings of percent number. They're trying a bunch of different exploits against all sorts of different applications. And this will be within minutes of an IP going live on the internet. So just because you haven't given anybody out your domain name or anything else, just putting the computer out there, within moments it will be attacked. And they'll try all sorts of things like that. Sir?
You mentioned, and also it was mentioned in the previous session, that for like cross-site request forgery, that there was some way to not rely on refer for anything. I am not aware of any way to actually have a refer be spoofed apart from when you already have control of the route. I'm not aware of any way to do a taking cross-site request forgery request and actually have it.
So think. There's plugins that you can add into Firefox and Chrome that will allow you to...
On your computer, but not on whoever you're trying to hack.
But I don't need to be on their computer. I'm making a request on their behalf, right?
Well, yeah, so I suppose if you're
if I've got control of their browser, I don't need to fake the refer. I can make it go through the normal flow, right? If I don't have control of their browser, then I can fake the refer, fake whatever I need to do. If the code that I'm attacking is relying on that, I can pass in the value that I need to make it think that everything's okay.
Right, so you can't get their browser to send a refer, but you can send the refer from your browser to go to the Anderson Chinese. Is that
Yes.
right?
There is another web app I'm going to pull up here. This is, I believe, hosted by Google. Let's see if I still have internets. And this is another good way to practice this sort of thing and get used to it. So this is on Google. It's called Gruyere. Does anybody know how to pronounce it? It's the cheese. Gruyere, okay. And so what you can do on here is somewhere in here, and I don't have this mirrored yet. When you start, it's going to create your own instance. So you can completely mess this thing up if you need to, but it'll start it just for you. I think it's on here. So you can either download this and use it locally, or you can use it on theirs, but they'll create your own instance. You don't have to worry about somebody else hacking and messing it up. There's also, as I mentioned, the DVWA, or the Damn Vulnerable Web App. Let's see. And there's YouTube videos as well that you can watch to see it all go. So you can download this. There's all sorts of vulnerabilities that are built into this thing for the purposes of practice. And this does allow you to change the security level as well. So they've got 3 versions of each of the exploits, with basically no security, moving up to a medium level of security, and then a high level of security. In addition to that, there's badstore.net. That might not be it. So you can download this demo, and they have a store. And in the store, you can do cross-site scripting attacks, you can do SQL injections, you can take over the database directly. There's quite a few things. So one of the things I've done at my company before is we set up kind of a hacking lab, right? We got everybody in the training room, brought up a VM with badstore on it, and said, okay, go at it. And we had the business people in there as well. And it scared the crap out of them. Because within moments, somebody had taken over the database entirely. They'd started cross-site scripting, so you would go to a guest book or something like that, and there's pop-ups flying all over the place and things going on. And so it gave the business people a bit of appreciation for what we as web developers have to deal with all the time. This is something we have to know in our jobs in order to do them effectively, is how to prevent this sort of thing from happening. And it's not all easy. But it's a lot easier to attack these things and show them, like, this is why we have to spend the time on getting the security right, is because this is what can happen. You know, we can go into the database and change prices. We can give ourselves things for free. On one of the companies I worked for in the past that I won't name, we had a web cart. And we built the web cart. It was all SOAP interface and happy fun times. But they decided that the front end of the website was going to be run by another company, by I can't remember the name of it, but this company would build the front end of the website, and then they would make calls when people added stuff into the cart through our APIs, right? Well, when the cart was originally built, we had all sorts of validation and verification on things like making sure that the price can't be below 0, making sure that taxes can't be below 0, making sure you can't have a negative discount, that sort of thing. Well, they decided, you know what? We need to have negative prices. So why do you need negative prices? Well, we want to run a discount as an item, and we want to be able to put that in the store. Okay, so we take that off. Now we've got to have negative taxes, right? Because a negative amount on an individual item has to have a negative tax associated with it, so you're not paying the tax on the positive amount. So we took out that validation, and so on and so on. It got to the point where I took a look at their application, and what they were doing is in their form, on their side, they were storing basically a PHP serialized representation of the cart item or the object that they were going to send in. So when you clicked on the button, it would post up this serialized base64 encoded data to their site. They would turn it into an object. They would wrap it all in SOAP, and they would send it over to us. Well, we had no way to say that that was not legit. So I was like, well, let's see what I can do. So I went into Firebug or the Chrome developer thing. I don't remember. I think it was Firebug at the time because Chrome was pretty new. And I took their thing out, and I base64 decoded it, and I modified the serialized string and posted it back in, and I got a penguin for $26 from this cell phone company. Oops. And I started doing other things. I started saying, okay, I want to buy these phones, and these phones are negative $24,000 a piece. And I want a lot of them. And so I put that all in there. And at the end of it, when I checked out, it said that they owed me close to $250,000. And it let it go through. And I put in, I did one on the real site as well. And I put in a phone for free. Our top-end phone, put it for free, and I shipped it to my office. And it got there. And I didn't pay a dime for it. And I told them, and they said, okay, that's cool. Let's fix it. Tell these guys to stop screwing up. But I got to keep the phone, which was nice. But somewhere in a box of stuff that I have from that company, I have the printout where I showed the card, and it had a penguin, and I even modified the image so it would show up there as well. But anyway, through going through some of this stuff, I determined that it was a good idea that I didn't really get into hacking until later on, because I would probably be in jail if I had done this a long time ago, because it's a whole lot of fun. Again, from the very beginning, I would recommend practice on some of these sites. Practice on Gruyere and Bad Store and DVWA. Try these things out. See what makes a web application vulnerable, and then go through and look at your code and see if you recognize any of those same patterns and fix them. Or better yet, see if you can hack your own site and then fix it. Yes? Yes. Mm-hmm.
That you're going to get back. So it's not necessarily, I'm assuming you're not necessarily talking about forms and then putting in information in a form or uploading it. But you're basically saying anything that you deliver to that browser and that they then send back.
Oh, absolutely. Because I can go in and modify those values, right?
Yeah, so did you mess with the DOM? Is that what you did?
Yeah, I mean, I could have done it through, I could have made the attack through curl, right? But I made it through Firebug, modified the value that was in that hidden field, right? So I took the value out, base64 decoded it, saw the string, modified the string appropriately, right? It's not terribly hard to read a PHP serialized string. Base64 encoded it again, and then pasted it back into that value. So then when I went over to him and I said, hey, look at this, all I did was click the button. The browser posted back that screwed up data. So it didn't have to look like, oh, you're doing hacker tools on the command line. It was in the browser. You know, and it was very, very easy to do. Steve?
So one other thing that I think is kind of the new thing, I guess, is with everyone using Ajax, everyone's got web apps that are, everything's going through their API. When my brother bought a company, and he had to kind of look at the code, and it was all these JavaScript, and they had a PHP backend that was sending stuff to their API, and it was just one file, but it accepted a SQL query for it to execute on tables.
Right. I mean, you don't even have to SQL inject that. You just pass the SQL in, right?
You know, it made the assumption that the application running, stuff sending to the API would only send good things.
Right.
Because they control the application, so that's good.
Right, and that's a bad assumption, and that's absolutely right. And I've also worked on and seen applications that did very similar things. I'm sure several of us have, where it sends a SQL query. That's horrible. We don't do that. You know, it's bad enough that the data can cause problems, but we need to make sure we're not also doing something that bad.
I'll also say one thing, with the SQL injection, the MySQL libraries they protected against a lot of SQL injection stuff for a long time. At least as far as the concatenating, using the semicolon and putting on queries. Unless it was using MySQL libraries, they don't allow you to use semicolons in passwords.
So I guess the assumption made there is that all the websites run on MySQL, and they don't. But yes. So a lot of times, and you will see, well, okay, so PHP Myadmin, I'm sure a lot of people use that one. PHP Myadmin will allow you to run multiple queries if you paste it in the box, right? You can have semicolons that will allow you to do that, but it's dealing with that on its own, to Steve's point. Other databases, SQL Server, Postgres, and more, will allow you to run multiple queries in the same execution point. So with the very beginning one with the users and the login, you've got a semicolon and another query that's happening, followed by a comment that basically says, ignore all the rest of this because we know it's going to be malformed, right? But yeah, it's a completely valid point. But that doesn't necessarily mean that it's preventing you from running SQL injection. It would prevent you from doing something like, say, running the select followed up by a drop tables or a delete query. So you can still SQL inject and cause problems on the first query, so allowing you to log in or do other things, see more data than you should. I've got one more example. I think how much time do I have? Okay, that's awesome. So we had a recruiting company that we were working with that we had brought some contractors on, and every week they would send me an email with the hours for each of the contractors and a little link that I would click on to say yes, approve this for payment or whatever, right? So I go and I click the link, and it had a little ID on it. It was letters, it wasn't numbers, and I'm like, well, I wonder what this is about. And so I changed it, and all of a sudden I saw somebody else's information. It's like, well, that's interesting, and I changed it again and so on. And then I put some junk in it, and I got a cold fusion dump. So it's not just PHP that can have this, it's any any language that can have these vulnerabilities. So Ruby's not safe, none of it, you have to take care of it for everywhere. So I changed that and was able to get into a list, and I got to see their entire customer list, everybody that they worked with. And so I sent this to them. I said, hey, by the way, you've got a serious vulnerability here. You can get in and see everything, and here's a screenshot of proof that we can do this. So the guy that wrote it came back, and he's like, oh, I've really done it now. I've figured out a way to encrypt it. I'm like, okay. He's like, you're never going to get in, never ever. He's like, oh, I forget, he bet me something, because he was so confident on it. So I go in there again, and I put in a bad character, and it caused enough of the code to display that it showed me his encryption key in the error output. So I'm like, well, that's interesting. Let's see how I can unencrypt this cold fusion thing, and I don't remember what the encryption algorithm was or whatever, but I was able to find some web form that I could put in the data and get back out the unencrypted with the key. And I did that, and I wrote him back about 5 minutes later. I'm like, here's your list again. He wasn't very happy, needless to say. But it goes to show, you need to have somebody, he was the only person in that company that knew anything about programming, and he was pretty junior at it as well. Anything can be vulnerable, so don't get too confident or anything. Basically, the only way you can completely secure a computer is to stick it in a bunker underground and cover it in concrete and make sure it's not plugged in. So with that being said, that's all I've got. And thank you guys all for coming.